All right, in the final part of the lab, I'm asking you again to insert a new map. And the new map I've asked you to call, and again, we're now familiar with this process. I'm going to right click, go to properties, and type in this case, precipitation. And click apply and OK. And then in this case, what I've asked you to add to it are the precipitation stations and the Indiana boundary. And we're going to, because this is drawing order, I'm going to move the precipitation stations above Indiana. And so now we've got our data set. We can, and we're going to do a lot of different ways that we can create raster data sets from vector data. And in this case, what we're going to be doing is two ways of doing that. And the first one is about creating a distance surface. And so a distance surface essentially says for every pixel in here, what is its distance to the nearest point feature? And what is its distance to the nearest point feature? So every pixel will have a nearest point. And so again, and this is a specific one, which is called the Euclidean distance. And that's, in other words, a flat distance, assuming there are no barriers in place. And so in this case, again, I'm going to go to analysis. And here we're going to put in Euclidean distance. And I'm going to be using the spatial analyst tool. Okay. And in this case, I'm going to say input raster. And we don't have that. We have a feature. And so that's our precipitation data. Our output, again, what I've asked you to do here for the output is simply Euclidean distance. And you'll notice that I don't have to put in the where it's going because it's defaulting to my home geodatabase. If you wanted to put it somewhere else, you would have to put it in here. Again, we're not going to have any barrier features. And what a barrier feature would be is something that would say you're going to have to calculate distance around it, or that it prevents you from counting through it. We're going to change our output cell size to 1,000 because, again, we're in meters. And so our output cell size, again, what I'm asking you to do is say output cell size is going to be 1 kilometer. That's essentially what we're doing here. So if I put in 1,000, and we're going to do planar distance, and notice that there is another option here, which is geodesic, and that would be distance over the Earth surface, or the ellipsoid surface. And so we're going to do planar now. In our environments, this is where this one's important. We're going to use the processing extent is going to be the Indiana boundary. And then I do want to clip this, and so we're going to use a mask here. A mask means the area that we're going to have actual data versus no data. And again, I'm going to use the Indiana boundary. Once we've done those two things, I'm going to click Run. And what we see now, and again, oftentimes the raster draws to the bottom. We're going to move that up to the top. And what you'll see if I kind of zoom in on this is that we can begin to see these divides between each area. And in fact, if I zoom in a little farther, you'd even see them more accurately. What I want to do next is what Euclidean distance does is for each and every point now we have an area that it's influencing more than any other point. And so if we were to measure precipitation, this would be a good way of doing it in terms of determining which points are most important in creating a surface. What I want to do next is compare this. And again, many times what we're doing in a raster environment is not all that different than what we can do in a vector environment. And so what I asked you to do in the lab was once you had run that, I'm going to ask you to, this is what I would consider a Thiessen surface. It's not Thiessen polygons, but it's Thiessen surfaces. And so we're actually going to create the vector equivalent, which is Thiessen polygons. So again, we're going to go to our analysis, tools, and we're going to put in, not surprisingly, Thiessen polygons. My input features again are going to be my precipitation stations, and we're now going to call, in this case, precipitation create Thiessen is fine. We'll leave it that way. What we want now is I'm going to associate with all of these, though, either only IDs, which is fine. That would simply give you the idea of the point, or all fields. Depends what you want. If you don't add all data, you're not going to have much there, and you would have to join that information. In terms of environments, again, my processing extent is going to be the Indiana border. And so we want to make sure that we have kind of the right information there. Everything else here is fine, but that's the processing extent. And so again, I'm going to simply click Run. And again, relatively quick. And now I'm going to make this hollow. I'm going to go again to our symbology and click on the palette, change it to a black. In this case, actually, I'm going to make it a thinner black line. And then I'm going to move my points up above so that we can see how all of this works. And so if I look at these areas now, what you'll notice is that the Thiessen surface and the Thiessen polygons actually kind of co-occur. I shouldn't say kind of co-occur, they actually exactly co-occur. And so this is a way of understanding how space and distance relates from point features to polygons and to raster. Now, once you've done all of this, what you're going to do is save your project, turn in the document that you've answered the questions in, and the screen capture of each of these 3 maps. So that's it for this lab. I hope this helps. We'll see you next week.